Hello everyone. So today we are going to firstly finish division of polynomials and then start a review. Last class we have covered how do we divide a polynomial by a monomial. And today we are going to learn how do we divide a polynomial by a polynomial which is not a monomial. For example, 4x cubed plus x plus 5 divided by x plus 2. This is a division of two polynomials. Do you guys remember what's dividend, what's divisor? When it comes to division, the two things in a division play different role. One is dividend, the other is divisor. Anyone remember which one is dividend, which one is divisor? Dividend, divisor. Is x plus 2 dividend or divisor? Is x plus 2 the dividend or the divisor of the division? Divisor, thank you. Exactly, thank you, Joe. The first one is dividend, and the divisor in this case is x plus 2. Very good, x plus 2. And the divisor in this division is not a monomial. So the technique we learned last class does not work here. We need to find a new method, and the new method is called a long division. There are other methods, but in this class, I only cover long division. Long division to process division of two polynomials when the divisor is not a monomial. So to get ready for the long division, we need to write both the dividend and the divisor in the standard form. Okay, x plus 2, divisor is x plus 2, degree is 1. 1 plus 1 is 2, and this divisor, this binomial, already in a standard form. Remember, the standard form of a polynomial contains n plus 1, that many terms. Let me say it again. The standard form of a polynomial contains n plus 1, that many terms. N here is the degree of the polynomial. The divisor is x plus 2. Degree is 1. 1 plus 1 is 2. So the standard form is supposed to have 2 terms. And the divisor already has 2 terms, x plus 2. And it's already in the standard form. Let's look at the dividend. The dividend is 4x cubed plus x plus 5. Degree is 3. The dividend in this division is 4x cubed plus x plus 5. The degree is 3. 3 plus 1, use the degree, add 1. 3 plus 1 is 4. So the standard form of the dividend is supposed to contain 4 terms. The dividend of this problem supposed to contain, the standard form of the dividend supposed to contain 4 terms. But look at the dividend, 1, 2, 3, is a trinomial. It only has 3 terms so far. Anyone can tell which term is missing? And how do we compensate the missing term to write the standard form of dividend? Degree is 3, right? So that's the leading term. And then we should go to degree 2. Do we have something degree 2? We are missing x squared, term x squared, right? We are missing x squared because we have a cube here, we have first power here, x is x to the power first, 5 is a constant, degree is 0, and we are missing the term with x squared. It is because the coefficient of that term is 0, so we write that term as 0 times x squared. So that's the standard form of dividend. So first again, a lot of people forget to do that, and they end up with the wrong answer. So please remember, to process a long division, to get ready for long division, we must write both dividend and the divisor in a standard form. Be ready. I'm going to take about 15 minutes to cover this question, one question. Try to explain how does the long division work as clear as possible. Okay, now we are ready. We are ready. I'm going to draw this division symbol like a roof, and then put the dividend under the roof. Put the standard form of the dividend under the roof. The standard form of dividend is 4x cubed plus 0x squared plus x plus 5. Standard form of dividend go under the roof. And the divisor, the standard form of the divisor go to the left side of the symbol, x plus 2. Okay, now we are going to follow the following steps. Firstly, we are going to divide, and then we are going to multiply, and then we're going to subtract, and then we're going to compare, and we're going to bring down. Let me explain. Divide. This is a procedure. The first step of the procedure is divide. Divide what by what? Divide the leading term. This is to take notes. You should take notes. Divide the leading term of the dividend by the leading term of the divisor. The first couple of times you might think this is too troublesome, but once you really understand the procedure, it is a pretty intuitive method. There is a box method for dividing polynomials. In some cases, that method works very well, but in general, it's not very intuitive. So I cover long division for the division of two polynomials in a case the divisor is not a monomial. So divide the leading term of the dividend by the leading term of the divisor. Let's follow the rule, follow the instruction. What's the leading term in the dividend? The dividend is under the roof. The leading term means the first term. It is 4x cubed. Okay, divide the leading term of the dividend by the leading term of the divisor. The leading term of the dividend is 4x cubed, as you can see. The dividend is under the roof. The first term is the leading term, 4x cubed. Use that to divide by the leading term of the divisor. Use the first term in the dividend by the first term in the divisor. Let's see what we have. Quotient rule. 4 stay on the top. X cubed is x times x times x. So we cancel 1x. The quotient is 4x squared. X cubed over x is x squared. So the quotient is 4x squared. And then we are going to place the quotient on top of the roof, align with 0x squared. Reason is because in long division, all the columns, all the vertically aligned terms must be like terms. The quotient for x squared has the variable part is x squared, so it must go the second column here, above 0x squared. All right, so first again, that's the first step, divide. Let me repeat the first step. Once we have the standard form of the dividend under the roof and the standard form divisor next to the roof, we can start a procedure. With the first step, divide. Divide what by what? Divide the leading term in the dividend by the leading term in the divisor. Pretty intuitive because the leading term, right? Dividend divided by divisor, and leading term of the dividend divided by leading term of the divisor. And then you're going to have a quotient, and you're going to place the quotient on top of the roof. We are going to find our quotient on top of the roof. So far, so good? We're not done yet, by the way. We have to go through all the steps in the procedure, and then we might have to go through the procedure a few times, depends on the problem. If you have no question, we are going to move to the next step, multiply. Okay, multiply what by what? We are going to multiply the quotient we just got by the divisor. Those sentences are guidelines, help us to go through the steps. So multiply the quotient we just got. What's the quotient we just got? The quotient we just got is 4x squared. And then we are going to multiply that by the divisor. The divisor is x plus 2. A monomial multiplied by a binomial. Let's distribute. 4x squared times x, 4x cubed. 4x squared times 2, 4 times 2 is 8, 8x squared. And we got the multiplication, 4x cubed plus 8x squared. And then where are we going to place that? We are going to place that under the dividend. Again, align the vertically aligned like terms, ax squared. We are going to place 4x cubed plus ax squared right below the dividend. Align the like terms. So far, so good? Let me erase that because we run out of space. Second step is multiply. Multiply the quotient we got from the first step by the divisor. And then you're going to place the multiplication, the result, the product, right under the dividend, like this. And that's multiply. Any questions? Any questions, guys? It is intuitive because it's very similar with dividing a number. You know, it's very similar with that process. It's just the dividend divisor, they are not numbers anymore, they are polynomials. Let's see. Okay, no questions? Awesome. So let's continue. Next step. Oh, not one, no. Subtract. Subtract what from what? Subtract the product we just got from step 2 from the dividend above it. You can reword it, by the way. This is how do I word it. I think it's clear, even it's not grammarly perfect. We are going to subtract the product that we just got. This is the product that we just got, the yellow, from the dividend above it. From the dividend above it. Actually, from the terms above it. Let me fix it. From the terms in the dividend. From the terms above it. But vertically subtracting is not very convenient, so this is what we do, okay? I'm going to, when we're supposed to subtract, this is what we do. We are going to change the sign in the product from in the yellow. Let me color it. So this is the product that we got from step 2. We are going to change the sign to the opposite. 4x cubed was positive, now we're going to change it to negative. 8x squared is positive, now we're going to change it to negative. And then you know what, we add them up. Change the sign and then we add them up. So vertically, look at here. 4x cubed, negative 4x cubed, they add up to 0. And right here, we have 0x squared. 0x squared plus negative ax squared. So the subtraction or the addition here is negative 8x squared. When we subtract the yellow from the terms above it, we have a negative ax squared. And then we're going to compare. Compare what? Compare the degree of the remainder. What is the remainder? Remainder is the negative 8x squared. Remainder. Compare that with the degree of the divisor. Bring down if the degree of the remainder is bigger than, strictly bigger than, actually strictly bigger than or equal to the degree of the divisor. Yeah, let me repeat it. Compare and bring down is pretty close, 2 steps. We compare the degree of the remainder with the degree of the divisor. If the degree of the remainder is not less than the degree of the divisor, we bring down. Let's see what I'm trying to say here. The remainder is negative ax squared. The remainder on the bottom, that's the remainder. That's the remainder. The degree of the remainder is 2. We are going to compare the degree of the remainder with the degree of the divisor. The divisor is x plus 2. The degree of the divisor is 1. Obviously, at this point, the degree of the remainder is not less than the degree of the divisor. So we have to bring down, okay? Bring down. Bring down the next term in the dividend. Bring this down. Plus x. Make sure everything vertically aligned are like terms. Very neat. All right? So far so good? Let me repeat, when do we bring down? We compare the degree of the remainder with the degree of the divisor. If the degree of the remainder is not strictly less than the degree of the divisor, we continue by bringing down the next term in the dividend. Let me know if I'm clear, guys. We compare the degree of the remainder with the degree of the divisor. If the degree of the remainder is not strictly less than the degree of the divisor, we continue by bringing down the next term in the dividend. Okay, thank you. Appreciate your feedback, response. And now let me highlight this guy in green. And the green thing is gonna be our new dividend, okay? The green thing is gonna be our new dividend. Forget about the original dividend under the roof. The green stuff, the binomial here, negative ax squared plus x, the green thing, that's gonna be the new dividend. The divisor is still x plus 2. Divisor remains the same. And you know what, we are going to repeat the procedure. We're gonna start a second round. Let's start a second round. The first step, divide. As I wrote here, divide what by what? Divide the leading term in the dividend. This is a new dividend, right? Again, the green polynomial is the new dividend. Second round, we start from dividing the leading term in the new dividend by the leading term of the divisor. The leading term of the new dividend, negative ax squared. Divide that by the leading term of the divisor, which is x. The quotient is negative 8x. Quotient rule. And do you remember where do we place the quotient? We place the quotient right above the roof. Make sure we align the like terms vertically. Negative 8x has exponent 1. So we place negative 8x right above positive x. And then multiply. Multiply the quotient we just got by the divisor. Divisor is still x plus 2. Let's distribute. Negative 8x times x, negative 8x squared. Negative 8x times 2, negative 16x. Those are something we have already covered last time. Multiply monomial by binomial. And now we are going to place the product right below the new dividend. Again, align the like terms vertically. Next step, subtract. Next step, subtract. We're supposed to subtract the yellow. We're supposed to subtract the yellow from the green. But subtract vertically not convenient. So my strategy is to change the sign in the yellow and then take the addition. In the yellow, we have a negative 8x squared minus 16x. Both terms are negative, and we are going to change them to positive. Positive here, and then add them up. Negative 8x squared, positive 8x squared, they cancel, right? That's what we want. X plus 16x, 17x. 17x. And let me double check, am I on the right track? 4x cubed plus 8x squared. Negative 8x squared plus x. And negative 8x squared minus 16x. So positive, so 17x. Okay. And now we compare. This is the new remainder. The degree of the remainder is 1. The degree of the divisor also 1. That means the remainder degree is not strictly less than the degree of the divisor. So we continue by bringing down the next term in the dividend, original dividend, the 5 here, plus 5. So we're going to continue. It makes sense that we have to continue because we did not use all the terms in the original dividend yet. And now let me color the thing in pink, this term, this polynomial. The pink polynomial is going to be our new dividend. After we subtract, after we compare and bring down, the pink polynomial is the new dividend. That means what? We're going to repeat the procedure one more time, the third round. Let's start the third round by dividing the leading term in the new dividend. Again, the pink polynomial, the pink polynomial, 17x plus 5, that's the new dividend for the round 3. Use the leading term of the pink divided by the leading term in the divisor. Quotient is 17. 17 go on top of the roof, align with the 5 because they are both constants. And then multiply the quotient we just got by divisor. And the product is 17x plus 34. And then place that right under the new dividend, right under the pink. 17x plus 34. And by the procedure, next step, we are going to subtract again. But instead of subtracting, we're going to change sign and do the addition. So both positive, change them to negative and then do the addition. 17x, negative 17x, add up to 0. 5 and negative 34 add up to negative 29. 5 minus 34 is negative 29. Okay, now we compare. This is a new remainder, right? Anybody tell me what's the degree of the remainder? What's the degree of negative 29? What is the degree of the negative 29? The constant term. That's a monomial. We agree last time. What is the degree of negative 29? Awesome. Thank you, Jill. It's 0. Perfect. It is 0. And the degree of the remainder is 0, degree of the divisor is 1, 0 this time finally is strictly less than 1. At this point, the degree of the remainder is finally strictly less than the degree of the divisor. And that means what? Means we are done. So the process, long division, we finish the long division when the remainder eventually has a lower degree than the divisor, then we are done. We are through. We did 3 rounds, the procedure, 3 rounds. And how do we explain the result? How do we explain the result? In this diagram, you can see that as a diagram. We have the dividend, original dividend, under the roof. We have the divisor x plus 2 next to the roof. And what happened on the top? This guy on the top, this is our quotient. This is the quotient. And on the bottom, this is the remainder. When we divide 4x cubed plus x plus 5 by the binomial x plus 2, we got a quotient 4x squared minus ax plus 17 with the remainder -29. The remainder is not 0 means what? Means the binomial x plus 2 does not go into the dividend 4x cubed plus x plus 5 completely. Let me give you another example like a number. For example, we have 205 divided by 3. 3 does not go into 2, but 3 goes into 20, 6 times. 3 times 6 is 18. Remainder, subtract 18 from 20, we have 2. Bring down 5, and 3 goes into 25, 8 times, right? And we have 24 with remainder 1. So when we divide 205 by 3, we got a quotient 68, remainder 1. That means 3 goes into 205 68 times, but not completely, with 1 remainder. There's one number 1 space cannot fill in. Same with here. The quotient is the polynomial on the top. The remainder is whatever on the bottom. Sometimes it's 0. In the case the remainder is 0, means the divisor goes into the dividend completely. Goes into the dividend completely. How do you write your result? You just need to write it in words. The result is 4x squared minus ax plus 17 with the remainder -29. Okay, guys, let me know if that's clear. It's a long process. Normally, I spend like 20 minutes. Now it's 6:29. It's more than 20 minutes. Is that clear, guys? Do you have any questions? I'm waiting for response. Do you leave it as it, or do you write out the quotient plus remainder? That's a very good question. Really depends on the problem. How would the problem want you to answer the question? I do not want to make it very complicated. Technically, we're supposed to write this way. By the way, you don't have to, okay? Because this go beyond what we need. So technically, the result is supposed to be quotient 4x squared minus ax plus 17 plus a quotient. What is the quotient? Numerator is the remainder, denominator is the divisor. There's a theorem support the way I just wrote the result. But we don't have to know that. I would say the question would ask you what's the quotient, and you just type the quotient there. And what's the remainder? The remainder is -29. And if we really need to write something which is equal to the division, that's gonna be the quotient right here plus remainder over the divisor. Okay, let me repeat it. Dividend divided by, restart. Dividend divided by the divisor equals quotient plus remainder over divisor. If we really need to write something, that's the thing. And this also tells us what? Polynomials. If we add the polynomials together, the result is still polynomials. If you recall what we have learned in the last class. If we add two polynomials together, the result is still polynomial. And no matter how many polynomials we add together, the result always still be polynomial. Same with subtraction. If we take the difference of any two polynomials, the result is still polynomial. Same with multiplication. If we multiply any two polynomials, the result is still polynomial. However, if we divide a polynomial by another polynomial, the result is not necessarily to be a polynomial. This is not a polynomial, okay? Because we have x plus 2 on the bottom, on the denominator. This is not polynomial. The addition, the sum of two polynomials is polynomial. The difference of two polynomials is polynomial. The product of two polynomials is polynomial. However, the quotient of any two polynomials not necessarily be polynomial. This is the result. We call this quotient is just the role that part plays in the result. The whole thing is not a polynomial. Okay, this is a long division. It's a very long process. We will practice more when we look at the review. All right. Do you guys ready for the review? Awesome, thank you. We have more people join us, don't we? Tevin, we have Ashley. Yes. Let me mark the attendance. I might forget if I don't do it now. Edit. So we have Tevin here. We have Ashley here. So the 11 participants. Save. All right, let's go to review. Review for exam 2. Exam 2 practice test.
You have me as absent, but I'm here.
Who?
Dakota.
Okay, let me see. So we have 11 participants. I must mark someone. Oh, Dakota. Okay, I apologize for that. Do it again. Dakota. Okay, so I have 12. Oh, one. Hold on. Someone I marked. Do we have Taylor here? We do. Ashley, Tevin, Jacob, White. That was here, right? Keelan, Joe, Amanda, Vilna. Oh, this girl. Didn't say. Okay, now it's 11. Very good. Review. Started. 40 questions. Same with the actual test. Simplify. Assume that all variables are non-zero. we're going to take our time. Copy paste on the note, then we can work on it. Simplify. If an expression has a negative exponent, it's not simplified. So let's see how do we simplify this expression. We are going to write a quotient bar or fraction bar, and we're going to keep 5 on the top and keep y squared on the top as well, because they do not have negative exponents, right? In the product, in the expression, we have 5 and the y squared going to remain in the numerator. And x to the power of -7, we're going to get rid of negative sign and write x to the power 7 on the bottom. Same with z to the power of -4. We get rid of the negative sign and write z to the power of 4 on the bottom. And that's it. Let me know if that is clear. Do you agree? Let me type. This is the quotient bar. Numerator, we have 5 y to the power of 2 y squared remain on the numerator, in the numerator. Denominator, we're going to have x to the power of 7 times z to the power of 4. Oh, be very careful with the z's here, and then to the power of 4. All right, guys? Questions? How about let me count to 5. If nobody answer anything, I'll just respond anything. I'll just keep going. 1, 2, 3, 4, 5. I want to make sure everybody understand. Okay, nobody respond. I continue. Use the formula for a binomial square to multiply. Okay, for this question, if you can use a formula, by the way. If you don't want to use the formula, you could just use the box method, because the system doesn't really care which method you use. The system only cares if you enter the right answer. I'll use both methods. The first method, we use box method. 7x minus a, the binomial to the power of 2, is the same with the binomial 7x minus a multiplied by itself. So this is a binomial times binomial. Our box gonna have 4 cells. Is a 2 by 2 box. We put a 7x minus a here and 7x minus a here. Let's fill in the cells in the box. Row 1, column 1, 7x times 7x. If you are not sure, write it down on your scratch paper. Please do not give me 14x. We're not adding, we're multiplying. 7x times 7x, 7 times 7, 49, x times x, x squared. So row 1, column 1, we have 49x squared. Row 1, column 2, 7x times -8. We're multiplying. Positive times negative is negative. 7 times 8 is 56x. Variable x remain in the product. Row 2, column 1, -8 times 7x. Negative times positive is negative. Negative 56x. And then row 2, column 2, -8 times -8, positive 64. And then we have a color scheme, remember, like a diagonal pattern, and that is pink. This is green. Oh, the color doesn't change. It's green. Diagonal. And this I'm gonna use, how about yellow? So from the pink, we have 49x squared. From the two greens are like terms. We can combine them, the two green. Negative 56x and another negative 56x. That make a negative 112x. And the yellow 64. And that's the result. You're going to type that into the cell. First method. Second method is to use a formula. I hope you still remember this formula. X minus y to the power 2 equals x squared minus 2xy plus y squared. A square of binomial difference. This actually is a square of binomial difference. Do not worry the name of the system. Sometimes they do not have the best name. Call this as square of binomial difference. The left side, the given expression is a square of OF binomial two terms difference because you have subtraction in the middle. And the formula we have proved last time, a square of the binomial difference is a perfect square trinomial with middle term negative. So term 1, term 3 are perfect square. In the difference of binomial, we have x minus y. The two items are x and y, or the two bases are x and y. So the first term is a square of x. The last term is square of y. In the middle, we have a negative twice of the multiplication of the two bases. So what we have here is 7x minus 8. So the first base 1, base number 1 is 7x. Base number 2 is 8. The given expression is the square of a binomial difference of the two bases, 7x and 8. By the formula, we're going to have a trinomial, perfect square trinomial. The first term is the first base to the power 2. First base to the power 2. The last term is the second base to the power 2. In the middle, we're going to have a minus, negative twice, and the first base times the second base. And then we simplify. 7x to the power 2. 7 times 7, 49, x times x squared. And in the middle, we have 92 times 7 times 8. That is negative 114 times 8. 112 x and plus 64. Give you the same answer. I believe most of you like the box method. As I mentioned last time, at this chapter, if you really cannot memorize those formulas, it's okay. Try your best, but if you really cannot memorize, it's okay because we have alternative methods. You can really just use the box method without worrying about those formulas. However, in chapter 6, you need to memorize those formulas. In chapter 6, we need to use those formulas. All right, guys, let me type in the answer. Typing in answer is very important. That's all that matters, to be honest, technically, to your score for the test. 49x squared minus 112x plus 64. Questions? 49x squared minus 112x plus 64. Oh, okay, no question. Awesome. And go back. And then next. Write the number in decimal notation. Oh, okay. So we did not cover scientific notation because it's a pretty simple thing. I think I can cover it while we're reviewing for the test. So this expression is a number in a scientific notation. This is about scientific notation. Scientific notation. what does a scientific notation look like? And why do we need to use scientific notation? First, let me demonstrate the looks of scientific notation. It looks like this. A box times a box, it has two parts multiplied together. The first part is a number, and the number has to be bigger or equal to that has to be bigger than or equal to 1 and strictly less than 10. The first part of the scientific notation, by the way, this is not x, this is a multiplication symbol. We use a cross, we do not use dot. In scientific notation, we have to use the cross as the multiplication symbol. The first part is a number, and the number must be a number bigger than or equal to 1 and strictly less than 10. 1 is fine, 1.2, 1.005, or 2 something, 3-ish, or 4, 5, 6, 7, all the way to 9 or 9.9 is okay, 9.99 is okay, but cannot be 10. Has to be a number in that range. That's the first part in the scientific notation. And the second part of the scientific notation is a power of 10. Is a power of 10. 10 to the power of n. N here is an integer. It could be 0. In the case n equals 0, then you just don't have the second part because it's gonna be 1. If n is an integer, if n is a positive, case 1, or if, let's write down if n is positive, the scientific notation represents a relatively large number. If n is negative, then the scientific notation represents a relatively small number. All right? So look at our expression, the given one. 5.5 times 10 to the power of 94. It has two parts. In the middle of the two parts, we have a multiplication symbol, the cross. And the first part of the scientific notation is number 5.5. It is between 1 and 10. And second part, it is a power of 10. The base is 10. Exponent is an integer. And that integer is negative. That means this scientific notation represents a relatively small number. Let's see, how do we know what number that is? What number the scientific notation is representing? All we need to do, now we know it represents a small number, right? So we are going to move the decimal point in the first part. It was right here. The decimal point is right here. We are going to move this decimal point to the left 4 times. 1, 2, 3, 4. 4 times. If we don't have anything, we just put a 0 to hold the place. Okay? All we need to do is to move the decimal point in the part 1, in the first part, 5.5. Move that decimal point to the left 4 times. Why 4 times? Because the exponent is -4. So we move the decimal point to the left 4 times. 1, 2, 3, 4. So the answer is 0.00055. Is a very small number, right? And this tiny small has 3 zeros in front of the non-zero digits. But what if we have 5.5 times 10 to the power of -12? Then this number is going to be very, very tiny. It's going to be 0.0000000. How many zeros we are looking for? 11 zeros. We're going to have 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. When we have a lot of zeros in a number, when we have to write a lot of zeros in a number, it's very easy to make a mistake. Like 1 extra 0 when it's not supposed to, or missing a 0 when we're supposed to have it. That's the reason we need a scientific notation. Scientific notation is a very organized way to record a very, very small number or a very, very large number. Same with a large number. If we have a very large number, let's say 1, 2, 3, 0, 0, 0, 0, 0, 0, 0, 0, when we have a lot of zeros, it's very easy to make a mistake, missing 1 0 or has 1 extra zeros. Then we could use a scientific notation to record this very large number. So how do we use the scientific notation? Let me see what is this number is. 1,000, million, billion, billion, trillion, so 1 trillion, 230 billion. Okay, anyways, very large number. So this is how do we use the scientific notation to represent this number. Firstly, we need to agree this is a whole number, but this whole number actually have a hidden decimal point. Is right by the foot of the last digit. So now we are going to move the decimal point somewhere to get us a number between 1 and 10. Because the first part of the scientific notation has to be a number between 1 and 10. 1 is fine, but 10 is no. So we have to move the decimal point somewhere to get a number in that range. If we place the decimal point here, and we get 123, that will be too large. No, we need a number bigger than or equal to 1 and smaller than 10. So we can't place the decimal point here. And then maybe we try here, still too large, right? And maybe we try here, between 1 and 2, and we get 1.23. And that is a number between 1 and 10. That's the first part. That's going to be the first part. Okay, that's going to be the first part. And multiply by the second part. Since this is a very large number, the second part is a power of 10, and the exponent is going to be a positive integer. What exactly the positive integer equal to? We just need to count the space between the two decimal points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is going to be 1.23 times 10 to the power of 12. And that's the scientific notation of this number, very large number. And let me know if I'm clear. So important thing is to grasp the looks of a scientific notation. It has two parts. In the middle, we have the multiplication symbol, the cross, connect the two parts. The first part must be a number bigger than or equal to 1 and strictly less than 10. And second part must be a power of 10. The base has to be 10. There's a reason we have this concept in this chapter, because this is an exponential expression, right? 10 to the power of n. And n here must be an integer. When the integer is a positive, this scientific notation represents a very large number. When the integer exponent is negative, like what we have here, the scientific notation represents quite a small number. Okay, ask questions if you have any. Okay, perfect. And before we keep going, I want to explain another way to handle this problem. Okay, let me just elaborate a little bit more. This is exponential expression, right? So it's 5.5. You also could just use your calculator, because 5.5 times 10 to the power of 94, by using the negative exponent formula, we are able to rewrite this exponential expression as 1 over the reciprocal. Remember the reciprocal? reciprocal of 10 to the power 4. And that actually gives us 5.5 over 1 times 1 over 10 to the power 4. And that actually is 5.5 divided by 10 to the power 4. And what is 10 to the power 4? Sorry, 5.5. 10 to the power 4 is 1, 0, 0, 0, 0, 4 zeros. And you can just use your calculator, divide 5.5 by 10,000 and get you the result. So that's another way to understand it or get a problem done. And we really use the information we learned in this chapter to get this problem done. All right, let's keep going. This is a 0.00055. Next, simplify. Type your answer using exponential notation. I strongly recommend when you take the test, please read all the information in the parentheses. Those information normally are very important. Let's simplify. How do I simplify? I would observe the looks of the expression and see the structure. I see a power of product. I see a power of product. And the base is a product. In the product, we have 3 parts. The yellow constant multiplied by the green x to the power 5th multiplied by the pink y to the power 8. I see a power of a product. The base is a product. The base is a product. Remember, power of product equals product of powers. Power of product equals product of powers. Okay, so right away, once we identify the structure is a power of product, you need to have this cue in your head. Power of product equals product powers, right? And then you're gonna rewrite this as a product powers. How do you do that? Yellow to the power 4, green to the power 4, pink to the power 4. You apply the 4th power on each color, on each factor in the base. Yellow to the power 4, green to the power 4, pink to the power 4, and then you simplify. What is 92 to the power 4? 92 times 92 times 92 times 92, positive 16. And then x to the power 5th and then to the power 4. Do you see the kangaroo structure? We use a power rule. It is beneficial if you memorize the cues that I included in my note. So this is the power rule. We keep the base of the base and multiply 5 and 4, 20. Y to the power 8 and then to the power 4. This is also a kangaroo structure. So power rule again. We keep the base of the base y and then multiply 8 and 4. 4 times a, 32. And that's it. And that's the answer, okay? 6 times x to the power 20 times y to the power 32. Questions? Oh, 16, my gosh. What happened is 16. What happened is, I don't know, I'm using a writing pad. Sometimes my hand like touching some other places on the pad, and it just somehow makes part of the writing disappear. It is 16, by the way, 16. Yeah, thank you, Amanda. It is 16. It never hurt. Be as careful as possible. 16x to the power 20, y to the power 32. Let me type 16x to the power of 20 times y to the power of 32. Before you submit, double check, triple check, quadruple check, because you only have one attempt. Okay, next. Graph the region described by the inequality. Okay. Let's do that. Do you guys still remember that? This is, oh, okay, I now remember. So this exam covers 2 chapters. I now remember. This question is from chapter 3. From chapter 3. Linear inequality in 2 variables. Linear inequality in 2 variables. When you see an inequality, when you see 2 variables, and you are talking about the environment is a rectangular coordinate system, 2-dimensional space. Even you missing 1 variable, you are looking at a linear inequality in 2 variables. So remember, how do we process or graph the solution set of the inequality? We firstly change the inequality symbol to equal sign. And we got an equation. And that equation is the boundary line of the solution set. Let's take a closer look at the boundary line. The boundary line is 4x equals -2y. I want to switch the 2 sides. I have -2y equals 4x. Same thing, right? And I don't like this -2 here. I divide by -2. I have y equals -2x. So y equals -2x is the equation of the boundary line. I put a +0 because I want to write it in a slope-intercept form. Do you agree, guys? The boundary line is y equals -2x plus 0 in a slope-intercept form. Okay, thank you. And how do we graph it? I'm going to find the y-intercept first, and then use rise and run, multiple methods. Okay, let me make it simple for us. Let's make it simple for us. All we need to do to graph a straight line, all we need to do is to find the 2 points. Okay, 2 different points would be enough. The first point, I let x be 0. If I plug in x equals 0 here, then the corresponding y would be -2 times 0. It's also 0. So 0, 0 is a point on the line. That's the first point we found. Second point, you can just be spontaneous, right? Just try to find a number that's convenient. How about let x be 5. If x equals 5, then y would be -2 times 5, then that is -10. I'm going to use these 2 points, okay? You can use other points. For example, you want to plug in x equals 1, then 1, -2 would be another good option. 0, 0, I choose those 2 points because I don't really want those 2 points too close. I want them to have a certain distance. So let's remember the 2 points. We plot them in the rectangular coordinate system. Okay, I'm gonna click here. Firstly, I click in the orange because the orange is on a straight line. And then I'm looking for 5, -10. This is a 5. Go down 10. Double check. 5, -10. All right. Very good. Question: am I drawing this line solid or like what I did or dashed? Should I keep it solid? It's a little while, but yeah, thank you. Solid. It's a little while. Yeah, we should keep the solid because the original inequality is less than or equal to. Very good. That's the first step. Next step, we are going to decide which side of the boundary line is the shaded region that represents the solution cell of the inequality. Unfortunately, we cannot use 0, 0 to be the testing point, right? We have to find other point. So this time I'm going to, remember we are done with the equation now. We go back the inequality. This time I'm going to use 5, 5. Okay, 5, 5, and then we're gonna plug in. So 4 times 5 is 20. 20 less than or equal to. -2 times 5 is -10. Is this a true statement? Is this a true statement? Of course not, right? It's false. False means what? Means 5, 5 is not a solution. Okay, let's remember that. 5, 5 is not a solution. 5, 5 is in the quadrant 1. 5, 5 is around here. It doesn't matter, it's in quadrant 1. It's not a solution, so I'm not going to shade that region, including quadrant 1. I'm shading the region excluding quadrant 1. So it's on the other side. And that's it. That's all it takes. Questions? Right after we have the boundary line graphed, we're done with the equation. You would have to go back to inequality. All right, very good. Let's continue. Divide. Okay, guys. I think I remember you guys do this question very, very good. I'll do it though. We do it together. Even you don't share with me, make sure you are practicing on your scratch paper. This is about division of two polynomials. What's the divisor? Divisor is the polynomial behind the division symbol. This is divisor. So this is a divide a polynomial by a monomial. That's something we covered the end of last class, last Wednesday. So this is what we do, okay? We write a dividend in the numerator. Write a dividend in the numerator and write a divisor in the denominator. And then we're going to split that one quotient into 3 different quotients and then add them together. And what are we going to do? If you remember, term 1 on the top over the bottom, plus, always use plus. Term 2 in the top over the bottom, plus term 3 in the top over the bottom. And then simplify. Don't rush. One step at a time. The first quotient, 28 over 4, 7. X 7th power over x 3rd power, 7 minus 3, 4. Second part, negative divided by positive, negative, -5, x cubed. 6 minus 3 is cube, right? And the last one, 12 divided by 4 is 3, x cubed will cancel x cubed. This question looks familiar. All right, guys, is that clear? You are welcome to ask questions. I don't want anybody wasting time here if you don't really get it. Every time we only have a limited number of participants respond me. What about any other? Are we all good? Amanda said, my biggest struggle had been chapter 3. Oh, okay. We'll practice more. Oh, thank you, Jill. Yeah, thank you for your response. Okay, thank you, actually. Chapter 3 is about straight line, right? Let's see. Let me type the answer though. 7x to the power of 4 minus 5x cubed plus 3. Double check. And by the way, the degree of the quotient always equal to the degree of the dividend minus the degree of the divisor. 7 minus 3 is 4. Your answer has a degree 4 polynomial that something consistent. 7 fourth power minus 5 third power and 3. Okay, next. Yeah, this one is a chapter 3 question. Read the instruction here, please. Okay, find an equation of the line that has the given slope and passing through the given point. Simplify your answer. Type your answer in slope-intercepted form. You would have to do what the system tells you to do. Use integer or fraction for any numbers in the equation. Okay, so we are finding the equation that satisfies the conditions and in the slope-intercepted form. Chapter 3 has a lot of formulas you need to memorize. Okay, so this is what I do. We are looking for the slope-intercepted form of the line, right? Let's say the line is L. I'm going to let the equation slope-intercepted form of the line as y equals mx plus b. You need to memorize this formula. It is pretty easy, not challenging to memorize, by the way. There's something wrong with the board. I think my hand, if my hand touch the board, is gonna erase something very weird. Y equals mx plus b. That's the slope-intercepted form. You need to memorize. No formula sheet. You need to memorize. And the slope is given is 97, so we are able to plug it in. Y equals 97x plus b. And we need to know the value of b. We don't know, but we can figure out because we have another piece of information that we can apply. What we do is we're going to plug x equals a half, y equals 6 into the equation y equals 97x plus b. Okay, let's do that. Y is 6 here equals 97 times x. X is a half here plus b. Be careful, your 6 and the b like write them in a formal way. Do not confuse one with the other. And we have 6 here. 97 times 2, that is 97 halves plus b. And we have b equals 6 plus 7 over 2. We have to keep a fraction because the instruction says no decimal. It has to be either integers or fractions. So b equals 6 plus 7 over 2. Tell me if I go too fast. 6 is 12 over 2 plus 7 over 2. So I have b equals 19 over 2. Once we have a b value found, we have the answer y equals 97x plus 19 over 2. I would say this is a quite challenging problem. The reason is because of the fractions. And the fraction part actually is from chapter 2. Once you're plugging in x equals half, y equals 6, and you are solving this equation for b, that is something we learned from chapter 2, linear equation in one variable. I moved this 97 over 2 over, so we have 6 plus 7 over 2 equals b. 6 is 12 over 2, so we end up with 19 over 2. Questions? Repetition make a difference. Practice make perfect. The only way is you really have to repeat. You see, you watch me solving it is just the understanding part. once you understand it, you have to really practice on your own. And you might feel that I wasn't really completely understanding it. But the more you practice by yourself, you will feel different. Questions? Oh, no questions? Okay. Let's type the answer. -7x 19/2. Type the equation of the line is, so y equals -7x plus fraction 19/2. I know you could easily convert 19/2 to decimal. However, look at it here. Use integers or fractions for any numbers in the equation. Please do not use decimal. All right, next. Multiply. Let's do this question. Box method. Box method. We are multiplying a binomial by a 1, 2, 3, 4. Four terms, polynomial. So this is a 2, this is a 4. We need a 2 by 4 box. 1, 2, 3, 4. Okay, it's a little bit more than I need here. Okay. I put a binomial on the side. 4x minus 5. 4x minus 5. I put the polynomial on the top. 3x cubed, negative 5x squared, negative 9x, 2. 3x cubed, negative 5x squared, negative 9x plus 2. Okay, so let's multiply. 3 times 4, 12. X cubed times x, x fourth. Row 1, column 1. Row 1, column 2. 4 times negative 5, negative 20. X times x squared, x cubed. 4x times negative 9x, negative 36, x squared. 4x times 2, 8x. Okay. Row 2, negative 5 times 3x cubed, negative 15x cubed. And row 2, column 2, 25x squared. Row 2, column 3, 45x. Row 2, column 4, negative 10. Double check. 12x fourth, negative 20x cubed. Negative 36x squared, 8x. I think if you know, you know. If you don't understand, you probably don't understand still. What I can do is you ask a specific question, and I'll explain. And let me color them. Remember, we have a diagonal pattern here. Run out color. This color. All right. So the purple or pink color gives us 12x fourth. The two blues combine like terms. Negative 20, negative 15 gives us negative 35 x cubed. And the two green gives us negative 11 x squared. Negative 36 plus 25, 11. And the two yellow gives us 53 x. And the blue is negative 10. Do you have the same thing with me? Be careful with typing in. Since it's very time consuming, I'm not going to type in. Okay, awesome. I think a box method is really convenient. very intuitive as well. Over years, I guarantee you will still remember it. We're gonna skip this one. We will not get 100% though. Next question, simplify. Let me simplify right here. So firstly, it's still negative, right? Remain negative. And 15 over 20. 15 and 20 have a common factor of 5. So divided 15 by 5, I have 3. Divided 20 by 5, I have 4. So that's the numerical part. The numerical part on the top and the bottom. And then we do the variable a. We have a to the power 8 in the numerator. We have a to the power 4 in the denominator. Numerator is dominating, so we have a to the power of 4. A to the power of 4 here. Hold on. A to the power of 4. And then we do b. We have b to the power of 3 on the top. We have b to the power of 6 on the bottom. This time, the bottom is dominating because the exponent is bigger. That's why we are going to have b, leftover b's on the bottom, b to the power of 3. Let me know if it's clear. 1, 2, 3, 4, 5. Awesome. And you mentioned mainly is chapter 3. This is chapter 5. Sorry. Next, still chapter 5. State the degree. Okay, what's the degree? Degree of the polynomial is 8, the biggest exponent. What special name describes this polynomial? It's a trinomial because it has 3 terms. That's so simple. Scientific notation. This is a very large number. So firstly, we move the decimal point somewhere to get a number between 1 and 10. It's gonna have to be 1.834. 1 point. Be careful, decimal point and the comma on the keyboard. One thing is when you go to the testing center, you are using a lockdown browser, and they will not allow you to zoom in, zoom out like you're doing this. If you don't see well, you can make it bigger and you can make it smaller. But with the lockdown browser, you can't do it. It's gonna be all small, so be very, very careful. Times 10 to the power of how many? Let's see, count it. The decimal point is right here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, power of 9. Questions? Okay, thank you. Next. Find the slope of the straight line that passes through the following pair of points. This is a very typical problem. Typical or classical problem means any book, any algebra book, it will have problem like that. And that means it's important. And let me read the instruction before we process the question. Select the correct choice below, and if necessary, fill in the answer box to complete your choice. We are looking for a slope. Sorry, we're only look for the slope, not a straight line. Okay, so remember we have multiple different methods. We can graph. We can use algebra method. Let's use the graphing method first. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We don't need that much. 1, 2, 3, 4. Oh, you know what? I don't want to use this method. Too much drawing. I don't want to use this method. I'm going to use algebraic method. Slope equals parentheses minus parentheses all over parentheses minus parentheses. And this is pretty convenient. I'm going to put one point on the top, the other on the bottom. So I'm going to do 14 minus 5. So 14 here, 5 here. And I do 5 minus 2. Since they're all positive, the algebraic method is a lot more convenient. 14 minus 5 gives us 9. 5 minus 2 gives us 3. 9 over 3 is 3. So the slope is 3. For this specific problem, the algebraic method is a lot more convenient. Is that clear? So basically you use, you align them vertically, and you use this to minus this, put on the top, and use this to minus this, and then put on the bottom. Be very careful with the calculation. Questions? Okay, so the slope is 3. Next, let's see the question here. That was an easy one. Yeah, I agree. If it has a negative sign, that would make it a bit more challenging. So I recommend that you use the structure, parentheses minus parentheses, and then you don't make a mistake with the sign, or less chance to make a mistake. There's a reason I recommend a certain method or steps. This question, the equation of a line is that what's the slope and what's the slope of a line perpendicular to it? Okay, this type of question actually is an easy question. All you need to know is the slope-intercept form and the theorem about the parallel and the perpendicular. So first part, since the equation is already in the slope-intercept form, y equals mx plus b, what's the slope? Parallel to it. Guys, parallel means two straight lines are parallel, means they have the same slopes, right? The slope is a over 9. Just copy exactly the slope is for the given straight line. And the perpendicular, remember, if two straight lines are perpendicular, their slopes multiply to -1. Or, if you remember, a new concept is called opposite reciprocal. If two straight lines are perpendicular, then their slopes are opposite reciprocal of each other. Okay, so the original straight line has a slope 8 over 9. Anyone could help me to find the opposite reciprocal of 8 over 9. Let me repeat my question. Could you help me to find the opposite reciprocal of 8 over 9? Perfect. Exactly. Very good. Exactly. Correct. That's right, Amanda. Is a negative. Be careful. Sometimes I even type the negative sign as equal sign. 9 over 8. Okay. Change the sign first, and then interchange the numerator and the denominator. Make sure the two slopes multiply to -1. Then they are reciprocal, opposite reciprocal of each other. Questions? Next, find an equation of the line that passes through the given point and has the given slope. Express your answer. Read the information in the parentheses. Simplify your answer Use integers or fractions, that means no decimals. Type your answer in the slope-intercept form. Slope-intercept form. So that's also very important. Let's see. We had a similar problem earlier. And seems you do need to handle fractions, so be cautious of that. Practice fractions if you need it. Firstly, let the equation we're looking for be y equals mx plus b, right? And then since m is given, we can just plug it in. Y equals negative 2/3 x plus b. We need to find the value of b. How do we find the value of b? Another piece of information, 9,2. Plug x equals 9, y equals 2 into y equals negative 2/3 x plus b. Let's plug it in. Y equals 2, put 2 here. X equals 9, put 9 here, plus b. And this equation, after we plugging in x equals 9, y equals 2, b is the only unknown. Let's calculate. I have 2 here, and negative 2/3. If you are ever feel like I'm stuck here, I hate fractions, and I don't want to continue. How about draw a scratch paper, like draw a box, and then put a problem in a box, and only handle that part, and then put it back after. So here we have negative 2/3 times 9/1. We can use the butterfly method. This diagonal, 9/3 is 3/1. So it becomes 2/1 times 3/1. All right, so this part, this wing of the butterfly, 9/3 is 3/1. 9/3 is 3/1. And it gives us negative 6. Okay, denominators are 1, numerators are negative 2 times 3, so negative 6. So this part is negative 6. Try not to guess. We are not gambling. I do have students, they guess all the time. We're doing mathematics. We are not gambling. If you don't know, you figure it out. You have to learn, right? You don't guess. How big the chance is you guess a math problem? So this is negative 6, and then plus b, and then you add a 6 to each side to isolate the b on the right side. You have b equals 8. b equals 8. So your answer is going to be y equals negative 2/3x plus 8. Let me type in. Y equals, don't forget you have a y equals. If you have a y equals outside the sum, then you don't type it. So really be careful. Y equals, oh, that's a minus sign, equals negative 2/3 x, negative 2/3 x, what is it? Plus 8, right? Double check. B is 8. You know, you can also double check by yourself. Slope is negative 2/3, no problem. And then plugging in x equals 9, y equals 2 to see if you have a true statement. 9 here, you would still have to do this part. Negative 6 plus 8 is 2. Questions? When we practice, we see this specific type of problem so many times. You know what does that mean? That means you probably will have same type of problem on the test. That means you really need to make effort and spend time to figure it out. Okay, awesome. Continue. Simplify. Divide. Okay, basically simplify. Since it's number, we would have to evaluate. We are looking at a quotient of two. Let me do that on my note. And do not forget to read the information. Do not assume. Figure out. Read the information. Simplify your answer. Use integers or fractions for any numbers in the expression. Type exponential notation with positive exponents. Okay, hold on. So this problem, wait a second. This problem here says type exponential notation with positive exponents. So it's not asking a specific number, even it gives a specific number. Okay, so I misspoke something, just to forget that. We don't have to evaluate. We just need to simplify using quotient rule. So we're gonna have 1 on the top, because we have 16s multiplied together. So the numerator is 16 times 16 times 16 times 16, 17 of them multiplied together. And the denominator is 16 times 16 times 16, 26 of them. Since the denominator has a bigger exponent, the denominator is dominating. So we would have no 16 in the top. We would have extra 16 on the bottom. How many extra? We use 26 to minus 17. 26 minus 17 gives us 9. We're going to have 9 extra 16s on the bottom. So the simplified form is 1 over 16 to the power of 9. We don't have to evaluate. I believe that, because here again it says type exponential notation with positive exponents. We have no negative exponent, and the result is in the exponential expression. All right, questions? What I'm trying to say is, do not spend effort. What is the 16 to the power of 9? Let me figure out and enter the number. You don't have to. If you do that, not only you waste your time, but also you lose the point. Read the instruction in the parentheses. Very, very important. I cannot stress this even more. Next, simplify. Okay. So I'm gonna work on this. I see a power of quotient. Okay. So we are going to get rid of the parentheses and apply the cube to the numerator and the denominator separately. Let's apply to the numerator first. Cube of 2x. So you have 2x times 2x times 2x. Think about it. The numerator, you have 2x times 2x times 2x. You have 8x cubed. Denominator is 3y squared. Let me copy paste. You see it better. Let me not rush. So basically, you have numerator is 2x times 2x times 2x. Same with the denominator. 3y squared times 3y squared times 3y squared. So the numerator, 2 times 2 times 2, 8. X times x times x, x cubed. Denominator, 3 times 3 times 3, 27. You have a y squared. Y squared means y times y. So the denominator is, you have 3y squared is 3y times y. 3y squared is 3y times y. 3y squared is 3 times y times y. And you count the number. 3 times 3 times 3, 27. And how many y's do you have? 1, 2, 3, 4, 5, 6. So y to the power 6. Okay? At least you need to know how to do that. 27y to the power of 6. Questions? Okay, thank you. Let's continue. Add, okay, adding with decimals, okay. Then you use calculator, right? I do not mind you use calculator. Let me observe and figure out a way to make it a... Okay, I'm going to use horizontal method. The reason I use a horizontal method is because I notice this is a cube. This is a square. They are not like terms. So if I use a vertical method, I have to, I cannot align them vertically without making modification. So I decide to use a horizontal method. Since we're adding, we could literally remove all the parentheses because this coefficient is 1, this parenthesis has coefficient 1, so we could literally remove them. So 3.4 x cubed minus 7.9 x plus 3.6 plus 2.4 x squared minus 6.2 x minus 8.5. Double check. When you have decimals, you're going to be very more careful. Let's identify like terms. This one and this one, they are like terms. And this constant, they are like terms. And the other two terms, this one and this one, they are not like terms. They are just by themselves, just to keep them there. All right. So we have 3.4x cubed plus 2.4x squared. The two yellows combined together, negative 7.9 minus 6.2. Use your calculator. Negative 7.9, negative 6.2. I don't want you to lose a point only because the calculation. This is not foundation 1. Foundation 1, you don't use a calculator. This is foundation 2, so you're fine. Negative 14.1 x. And the green circle 3.6 minus 8.5. Use your calculator. We're going to have 4.9. All right? Yeah, that's your answer. Be very careful. Since it's very long, I'm not going to plug in the system. Do you have the same answer, guys? Adding. Yeah, I guess because the adding polynomial is very easy, they make it a little bit challenging by using decimals as coefficient. So that's the question, number 17. Next, dividing. Okay, I can do this right here. So term 1 over the bottom, 16 over 4 is 4. 4y squared. 4y squared. That's the first part. First term. And then second term in the top over the bottom, going to be negative 3. 12 over 4 is 3. Y cubed over y squared, we have 1 extra y on the top. And then minus 8 over 4 is 2. Y cubed, y squared cancels y squared, and that's it. And you have done this multiple times, right? I believe you understand this. Let's continue. You want a chapter 3 question. Most of them are chapter 4, right? Chapter 5, sorry. And this one is even more straightforward. one application of one rule, power rule, because this is a congruous structure. You're going to have a to the power of 8 times 9. Please don't add them, multiply. Your power rule, when you have a congruous structure, you multiply the two exponents. 8 times 9, 72. And this is also very straightforward. You're looking at a multiplication of two powers with the same base. Again, use positive exponents only. Multiply, leave your answer in exponential form, so do not evaluate. Base remains as 9. Since we are multiplying two powers with the same base, we are applying the product rule. Product rule, we add the two exponents, 13 plus 15, 28. This one is more straightforward because simply 9 to the power of 13 is 13 nines multiplied together, and you have 15 nines multiplied together in the second parenthesis. So together, combined together, you have 28 of them. So 9 to the power of 28. This is from chapter 3. We are graphing the equation. Be sure to simplify the equation before graphing it. Read the instruction. Very good instruction. Remember to simplify before you're graphing it. Let's simplify first. 6, 3, 9. Well, they have a common factor. Not only that. I can move 3x over. Move 3x over. So I have negative 3x. Keep 6 on the left side. Okay? So 9x minus 3x, 6x. Or we can switch the sides. 6x equals 6. And then divide each side by 6. We have x equals 1. X equals 1 is a linear equation in two variables. At this point, you should, if you paid attention, you should remember, even we do not have a y, variable y, in the equation, this is a linear equation in two variables. It represents a straight line. I want to ask you, is this a vertical or horizontal straight line? I want to ask you, is this equation a vertical or horizontal? Vertical. Vertical. Yes, correct. Is vertical. Vertical straight line. X equals 1. So let me draw the vertical line. X equals 1. So do that. And then x equals 1. So this is a horizontal line, right? This is the orange. No, this is orange. Go to the right 1 unit. And then draw a vertical line. And that's it. All right, that is x equals 1. Just find x equals 1 and draw a vertical line. Next. So I'm not going to submit, otherwise I'll lose the thing. So I'm going to just close the tab, and next time when I ask to the assignment, we should still have whatever we done here and the same test. We won't have to do the different test. So I'm just close the tab here. Okay, so that's for today. On Wednesday, we'll continue reviewing. I know chapter 3 is challenging. You are welcome to email me if you have any questions. All right, guys. Thank you for coming. I'll see you on Wednesday. Have a good night. Bye-bye.